Okay, so this lecture is supposed to kind of follow up with nomenclature. It seems that the section with polyatomic ions has been cut out inadvertently, or it's been zipped up or something. I think maybe the file was just too big. I'm not sure what happened, so kind of doing a follow-up for that for those of you that may need just a little bit more information about polyatomic ions. But I'm backing this up just a little bit, and we're going to talk about binary ionic compounds. These were the first group of compounds that you guys learned to name, and we said that the metals tend to form positive ions. They're called cations, and nonmetals tend to form negative ions, and they're called anions. So cations are positive and anions are negative. And the way that this works is, of course, you name the cation first, then follow it with the anion, and then, of course, it shows its suffix IDE. So for NaF, the name of the first element is sodium, and then, of course, the name of the next element is fluorine, but we're going to change that to fluoride. So the IDE kind of shows it's been married. Let's take a look at this one here. Oh, my bad. Okay. And so we're going to name the first element. It is calcium. And then, of course, the name of the second element is chloride. Excuse me, it's chlorine, but we're going to change it to chloride. See, I'm already in nomenclature mode, naming mode, I guess. Okay. Let's take a look at this one here. So this one is cesium. So let's name cesium. And then oxygen becomes oxide. Okay, and for this one, let's name the first element. It is calcium. And the name of the second element, of course, is oxygen, but it's going to become oxide. Okay. Now this one's going to be a little bit different because this is what we consider a type 2 binary ionic compound, but it's with a species of variable oxidation. So let's name this one. All right, so let's name the first element, iron. Okay, now, there's something really bizarre going on here. This too, I know, belongs to oxygen because oxygen is in group 6 and only needs 2 more electrons to have a full octet. So that means that this 3 belongs to the iron. Well, because it has more than one oxidation state, and iron has 2 of them, has a +2 and a +3, I have to write with Roman numerals to show this oxidation state. And then I'm going to name it as I would anything else. So this is iron 3 oxide. Let's take a look at the next slide. All right, now this is the one with the ionic compounds and polyatomic ions. And this is just a list of some common polyatomic ions. You see acetate in here, ammonium, there's even some nitrate, oxalate, can't even say that, perchlorate, permanganate, phosphate, so on and so forth. So be very familiar with these. You'll see a lot of these show up, especially when you take pharmacology or you get into pharmaceuticals. A lot of the names of the compounds that do make up the drugs are going to have some of these members. But the rule stands to be the same. You're going to name the first element. Let me skip this up. So the first element in NaNO3 is sodium. So this is sodium. And then this is a polyatomic ion. Now, how did I know? Well, first of all, I memorized it. But second of all, I just kind of looked at my chart here. And, oop, I see the NO3, just like it is here. And so, sodium, its name is nitrate. Hold on, I'll scoot that up. Yeah, it's sodium nitrate. There she is. Okay, let's try the next one. So this is, name the first element, just like you have been doing. Nothing different there. So calcium, and I believe that it was CO3. So let's go to our list and see, there is carbonate. So this is calcium carbonate. Okay, let's go over here and name this one. Lithium. And then the OH hydroxide. Okay. Let's try to name this one here. Okay, so let's take a look at this one. Okay, all right, so now I'm going to name the first element. The first element's name is hydrogen. Okay, and I'm looking at my list, and I don't see this one on the list, so I ended up venturing out to, I don't know, some site on the web. I just typed in Google, find me polyatomic ion table. And it could be even in your online textbook. That would be another great source for you to look. But this thing right here is called peroxide, and her formula is O2, and it's -2. And that's just one of those things that I committed to memory. But you guys, and I bet every one of you are familiar with peroxide. So let's take a look at this last one here, or next to the last. All right, so this one is named the first element. It is potassium, and then MnO4. I'm going to go down here and see if it's listed. Right there it is. So it's permanganate. And a lot of students a lot of times will say, you know, do we need to, you know, memorize? And well, if you plan on pursuing aspects of chemistry and pharmacology, I would say yes. Go ahead and commit some of these to memory. It's not too hard, and you'll end up working with them way more than you thought you would, but it'll make your life a lot easier. But as far as I go, I'm not requiring it. Now this is very similar to the one that we saw before, but this one's going to be a little bit trickier because now we've got to figure out what the oxidation state is. So I'm going to use my polyatomic ion as a clue. So let's go see if we can't find this PO4 business. Oh, there she is. PO4 -3. This is phosphate, so there's a -3 charge, but I don't see a 3 anywhere in this formula. So what that means is iron was a +3. Phosphate is a -3, and because they have like charges, they cancel out. So the name of this little monster is iron 3 phosphate. Now for this next slide, we have where we have to write the formula, and my formula is going to be a little bit screwy just because exponents, and I'm hoping that it'll show up on here. But okay, so they give me the name of the compound, and they tell me that its name is calcium nitrate. Okay, so I'm going to write Ca, okay, and I know that Ca has a +2, so let me try this. Okay, it has a +2, okay. And then it says nitrate, and I went back to my list and I looked up the formula for nitrate, and it just so happened to be let me mash that button. Okay, NO. All right, now I need a subscript 3, and I'm going to put -1. Okay, so this is the formula that I got from the previous slide, from that little list right there. And when we're making our compounds, we have to crisscross our charges, because remember, those charges are telling me how many electrons are being given and how many electrons are being shared at any given time for this compound. So let's go over here, and I'm going to try to do this. Okay, so we have Ca, parenthesis, NO, and I'm going to do a subscript 3, parenthesis, parenthesis, Now, so what I've done is I've encapsulated the NO3 to show that it is one unit, to show that it's a nitrogen and 3 oxygens, and it must stay together. And I'm going to put a 2 on the outside because that 2 came from calcium. I don't write the ones. Ones are understood. Okay, let's look at that. Let's look at the next one here. Okay, so the next one is potassium permanganate. Okay, so I'm going to write her chemical symbol, potassium. And she is a +1 because she's in group 1. And then permanganate, I'm trying to remember the formula, but I can go back and look at the previous slide, or I can look online, or I can find it in my book. But it happens to be MnO, oops, my bad. I keep forgetting to do that. Okay, so MnO4, I need a subscript, so permanganate, and it has a -1 charge. Okay, so crisscrossing the charge, well, lo and behold, these are the same charge, excuse me, the same number, but opposite in charge. So it's going to be KMNO4 because the charges are going to cancel out. Okay. Let's go to this one right here. This one is a little bit tricky because it didn't include any Roman numerals. Now, the funny thing about lead is it's not in the D blocks. In other words, it's not in the middle of our periodic table. It's actually in group 4, and its chemical symbol is Pb. So let's do this. I have Pb, and I know that this is a +2. And let me tell you how I know. The 2 is not listed here as a Roman numeral, but I see the sulfate ion, and the sulfate ion is SO4 -2. So they canceled out. So let's write her name. And I want you guys to use the Roman numerals. I just don't feel like you can ever go wrong doing that. So lead 2 sulfate. And it's PbSO4. Okay. So I do want you guys to get in the habit of doing that. And the last one that we need to look at is potassium phosphate. And potassium phosphate, of course, is K, and it has a +1. My bad. +1. I'll get it out here in a minute. Maybe +1. And then the phosphate group is PO4 -3. So I'll put it up in the right spot. So clearly you guys can see it's going to be K, P3, P, come on now, PO4, and that is potassium phosphate. And then the last one right here, you add the word hydrogen, dihydrogen, whenever hydrogen is added to the anion. So the anion happened to be the PO4, and this is only true when there's a cation and an anion present. And so that is zinc. Okay, so here is zinc 2 dihydrogen phosphate. So I have told you in its name how many hydrogens are present.